Okay, thank you for your participation, for those of you who participated, and then thanks for allowing us to come by.
All right, so let's talk more about the assignments. There was a comment about assignment 2 and the use of MongoDB. Because we have to use MLabs as a hosted deployment of the MongoDB. I tried it out with the MLabs directly, but there was a comment that if you want to make it a little bit easier for yourself, you can do it via the add-on on the Heroku platform, and then the management of the environmental variables and the login credentials are a little bit easier because they are taken care by the add-on. Otherwise, if you go to MLabs website, you have to register a user, you have to do everything manually, and then you have to initiate the environmental variables manually on the Heroku to make it possible for your deployment to talk to the database. But the side effect is, not side effect, the downside is that you have to give up your credit card details on Heroku, otherwise the add-ons are not available for you. So if you want to make your life a little bit easier, you could do this path, or you could just do it manually with MLabs. Yep.
Can we also host the website ourselves?
No. So for this assignment, the whole point was to use MLabs and to get a feel of how much mucking around there is to kind of get the two services talk to each other. They are independent. They have nothing in common. So Heroku and MLabs are not in any way kind of joined, and we wanted you to experience how you would do that. This will happen in assignment 3. So in assignment 3, you will be able to host it yourself and do everything yourself, actually. You will not have to use Heroku, and you will not have to use MLabs, neither. But that's for assignment 3. All right, so I talked about this. There is question about how to deal with 2 executables in your Go package, in your Go project, right? So we have a Go project, and now whatever you've been doing, you have to refactor your code to have 2 executables, because one will become your web app and one will become your clock. So you will end up with 2 executables, right? So you have to have 2 things which have the main function, which become an executable, okay? And to get the long story short, if you go to the repo, there is a repo which kind of showcases how to do that. Before I will explain it, I want to talk a little bit about secrets, because I did some bad things in the past. One of the bad things I've done is I included my Discord channel webhook key inside the repo out of convenience for testing, so I could deploy it on Heroku, get it going quickly, and I don't have to fiddle with environmental variables. And kind of for testing purposes, I hard-coded my Discord channel private key kind of thing into the code. You should never do that, right? But, you know, and I should never do that neither, but I've done it and it's in the repo. So I'm not proud of it. I'm kind of, you know, it's a bad thing, I admit. I really discourage you to ever do those type of things. You should always try to use environmental variables and keep secrets secret. Never put them into the repo, right? I don't want to spend much time on it. Christopher will talk about it later. But the bottom line is that the example which is here has this kind of a secret key built in. How bad is it? Well, it's not too bad. I just go to Discord and I, you know, invalidate the webhook, you know, in the next 15 minutes, and then nothing bad will happen. But for the next like 15 minutes, if someone really wants to abuse it, they could, right? Because it's out there. And the bad thing also is that the repo is on GitHub, and it is a public repo, right? So people could have been abusing it for a long time now. Anyway, so you should not do that. Okay, so now coming back to the repo, if I switch that. Okay, so how do we deal with packaging in Go? What we do is we typically organize, as you see, we organize things into subfolders, right? So in the assignment 1, we had everything in the plane just right here because we only had a couple of files and one executable, and it was very straightforward just to have everything flat in the base level. Some of you did a subfolder, which throw out some of the problems with the testing later on, but those of you who want to do subfolders now, you are encouraged to do so, right? So you kind of split your logic into a single subfolder in your case, because you only need one functionality for the currency conversion thing, right? So it can be just a single subfolder, which will have, so let's go to this one, which will have kind of your logic, right? So if you go, say, to student.db, you will see that there is a number of files, and if you go to one of the files, you will see that it says a package is student.db, right? So you will have your own package with the logic of your web application, right? And that logic will consist of your utility files and your functions to call fixer and to check MongoDB and so on. You can split it into multiple folders, but it's kind of better if you keep it in the same folder but split it into multiple files, logically organized. So things to do with Mongo, just keep in some Mongo file. Things to do with fixer, keep in fixer file. Things to do with the HTTP request, you call, responses or something, and keep it organized within that folder, right? And then your package will be whatever your package name is, right? And then you need to build two executables. So the way most Go projects do that, they have a folder called command, CMD. And then if you go there, you see two subdirectories. And those subdirectory names become the names of the executables that you will build, okay? And then if you go to any of those, you will see that there is only one file called main.go. And this main.go will be in the main package because it's an executable, right? So the project structure looks like this. You have your folders. You have some logic package folders which you kind of have your logic in. And then there is one folder called CMD with subfolder per each executable that you need from your project. And that's it. And both of those have the main.go files, and each of them is in the main package. And then what you do is, when you're building it, you basically will specify go build whatever your GitHub or whatever repository is, /cmd/ and the particular folder name. And it will generate, and if you say install, it will generate and install the particular executable in your go path/bin folder. And that's how Heroku will deploy it as well. So can you go one level up? So those two executables, go one level up, yeah. Those two executables are, executables for the clock and for the web app that you will then specify in your proc file. There is one extra thing. Because we're using MongoDB, you have to use vendoring. So if you go up, you will notice that there is a vendor folder, and the vendor folder has a JSON file which specifies several dependencies. So in this case, it specifies the Mongo driver, and then the Bison, and then some internal things that the code, the student DB code is using. So you should handle your external dependencies using the vendor mechanism. And it's kind of well documented on Heroku website. And if you have trouble, we can help you tomorrow as well, right?
You mean the Go vendor or Go devs that generate this along with the prog file, and then you edit them?
Yeah, that's right. Okay, so that is about Go packages. Do you have any queries about the Go packaging? Do you understand? Okay, you go first.
file and you drop it directly.
Say it again?
Use an app.json file, is that relevant?
Yeah, let me check.
It's just info.
Yeah, that's just the info description for the project. So that's not.
But
And then the proc file in my case has the. So if you go to a proc file, it has the. I've been testing the clock and the web. Yeah.
if you go back to vendor.json.
Yep.
You have to manually do these things. Install.
I did it all manually, yes. And I mean, I did this manually.
Yeah.
And then you have a Go vendor tool which does all of that automatically. Yeah.
Governor.
Yeah, Governor. Yeah.
Here when it installs your apps.
Yeah, that's right.
And
So that basically means of what are the executables that the Go install will use. Yeah.
Could I request that you comment your code a little bit more?
Sure.
Yeah, because I may not understand the context of all the code that you.
Yep. So put a like a request in the system. So like say which line or what is not clear, and then we can
But
discuss
even
that.
like what he asked now, in the vendor file, on top, you could say what is the file for, what is it.
Yeah, but that's explained on, let's say you want to deploy it on Heroku and they will tell you external dependencies should be dealt that way. So that's just following the tutorial there. Yeah. Okay. Any other questions about the packaging? It is not that obvious how to do it, but once you kind of organize your code into the sub package and the commands that you will generate, it kind of makes sense. And your main.go can become a bit fatter because anything that you don't exposing to the outside and kind of makes your logic kind of glued together, you can actually put into the main.go. So in fact, in the subfolder in command, if you have to use more than one file, you could, if you just want to put more logic in there. The point of the package is that you have something that can be reused in other applications because you can refer to it. It's sort of like a unit of work that you can reference from other packages, right? So if there are things specific for a particular executable, it may make sense not to keep it in the package. It may make sense to keep it in the main.go or that command folder. Yeah?
Yeah, one thing worth mentioning is that you have to use the entire absolute file here when you.
That's correct, exactly. So you cannot mix it. So either you go with relative paths and then you build and do and reference everything relatively, or you do a proper global paths, which then allow you to build and inject the builds into your Go path. Yep.
Is that a file system path or is it actually GitHub?
It's actually GitHub, yeah. So that is referring to the global namespace, and it will actually fetch, if I haven't imported it, it would kind of fetch it from GitHub, right? So on assignment 1, we've been using like local host or something here to kind of refer to our local files. You can do that this way, right? You can have stuff in your Go path which is not on GitHub or not anywhere publicly, which is fine, but then it gets a little bit tricky with the referencing of the dependencies and so on. If you prefer not to publish your work and not to use the actual Git repo, then you may try using a kind of a prefix here, which is the one which you use in your Go path for your stuff, right? Okay. So assignment 1, we decided to modify the text. So please check the text. The default base is euro. If you want to do it for other currencies that the user registered, feel free to do that, but it's not required. You can just simplify your code to just use euro. There was a question about historical data. So we decided with Christopher that we will change the requirements. Oh yeah, by the way, did you change the text already?
No, not yet.
No. So we changed the requirements, and we will require you to keep historical data for 3 days, not 7 days, right? So we can ask, okay, what was the last 3 days average? Instead of asking what was the last 7 days average. What it means is that whatever you do, like, okay, if you deploy your system, you basically don't have historical data at that point, right? And we don't care because we will wait 3 days from the moment you deployed your system in deadline to do the tests. So you should have the 3 consecutive days until we start the tests, okay? It was a little bit messy of being able to test on a cold start where you have to either generate some historical data or just catch the current data and use it as if it's an average of the last 3 days and blah, blah, blah. It kind of gets a bit complicated, okay? So to simplify your and our life, we will not test on a cold start of what you have in the period which precedes it, but you have to start your services on the deadline, and they have to keep running until we test them, which will be 3 days later, and you will have the 3 days data, okay? Yep.
Because of the 7-day thing, I've done a kind of hacky solution where every day I go back 7 days and fix trial and take the average.
Okay.
Is that okay, or do I have to?
It's okay. I mean, it's okay, but with the new constraints, you can simplify your code, right? So that logic is fine too. You just need to change from 7 to 3 now. Yeah. Anything about this? Yes, there was one more question about that. So the update of the currency happens on Fixer at some point, and also you at some point check the data. So what may happen is that we check the Fixer, we store the particular value, and then a minute later Fixer just updated the currencies for the next day, because they keep data for like 24 hours. We don't know exactly when that happens, and we don't know exactly when you update your database for that matter, right? So when we ask you for the current currency and you give us a value, it can be either today's value or it's yesterday's value, right? Because we may have this kind of a relative shift. So both answers are correct, okay? We don't care. So if we ask you, okay, what's the current rate of the euro in NUC, and you give us a value and it's today's value, that's correct. If you give us yesterday's value, we will kind of assume we just have this a bit of a race condition happening, and we will also say that's correct as well. Okay? Yep.
When you have like the latest handler, should you return the latest entry in the database that has been recorded, or should you then immediately check Fixer and return the absolute latest one that's possible to get?
Well, so it's up to you. I would think that you would kind of decouple the Fixer from your database. So you would, when the request comes, you would just get the data from the database for the reasons which I will discuss in a bit. But if you want to double check with Fixer and get the really latest one and update your database, that's okay, but it complicates your logic, because if you've just done it and you have a data for that day, there is no point asking Fixer for the next 24 hours because the value will be the same, right? Yeah, it's up to you. I recommend just doing the simplest way, just updating your database in the clock, and upon request, just reading the data from a database. Yep.
You described what I'm actually doing right now, and if you run on Heroku, the web application,
Mm-hmm.
I have to separate the two executables, and basically now one does the same. But should I just
So ask me the final bit again.
I have to separate out the functionality.
Yeah,
but
into
I,
two executables. Yeah.
I use most of it in both.
Yeah.
So should I just upload two very similar versions that doesn't instantiate the web server on one?
Yep. Sure. Yep. You can do that. Yep.
If you go into Fixer.io, it states that they update daily around 4 p.m. CET.
Mm-hmm.
So if you take like an hour or two after that,
Yeah. It should be relatively safe. Yeah. Exactly. But that also requires you to launch your clock, because if we use clock and sleep like we do, it kind of starts upon your start, right? So you would have to kind of start around 5, say, p.m. to make sure your cycle is correct, right? So yeah, it kind of complicates life somewhat. So sure, to be on the safe side, you can do that. You can always check the local clock. If it's after 5, you know what time do they use for Fixer? Is it European time or?
CET,
Yeah, okay. So then you could kind of actually check with that clock and say, okay, I will sleep for as long as it takes me to get to 5 p.m. on the day, and then I will kind of ask the data. You could do that. Yeah.
Then the question is it summertime or wintertime?
Exactly. Yeah. Okay. So that's about the historical data. Okay. So there is one thing that we left here in this corner. Remember when I was talking about scaling? It's actually quite big topic, and Christopher will talk about it more in subsequent weeks. But for today, I want only to convey some general principles. So let's say you've built a web app, you've built a service, right? So let's say it's a kind of a currency ticker, right? So I can ask, what's the current currency exchange rate between this and that currency, right? So I have kind of a service, and I have people requesting data, and I have to respond, right? So what happens in Go is I have a thread per request that handles the request and sends the. So if I have multiple of those coming in, right? I am kind of creating multiple threads and handling that. And at some point, the box on which I'm running runs out of resources, right? So at some point, I will saturate how the service actually behave. It will kind of have, let's say, denial of service attack kind of thing, right? Because I'm asking the next query comes, and it hits the wall because it can't be handled, right? So how you deal with that? What can you do? So I have my machine, say my laptop. I launch the currency ticker on my laptop. I open up the port, and now you guys are asking me, okay, what's the exchange rate between that and that and that and that, right? And at some point, it stops working, right? So what can we do? Yeah, you can, but you want to serve everybody, yeah? No, it will not help. We need to bring another laptop, right? You need to say, okay, let's hypothetically say this guy handles like, I don't know, 20,000 requests per second, and that's it. It can't handle more, right? So if you want to handle 40,000, right? Well, you need to bring a new laptop. And on the entry, you have to multiplex it, right? So now we have two laptops doing the same thing. The request comes, and then I have to load balance, right? Which one is more busy? Is this one more busy than this? So I have to have some sort of a load balancer which kind of directs the request to one or the other box. And then if this one was 20K per second, and this one can do 20K per second, then if I do this well, on here, I can have 40K per second, right? So this guy doesn't do anything. It just redirects the requests, and then I'm responding, and I can do now 40, right? So now what happens if I get extra people asking? I'm already on my limit on 40, and new people come. What happens? Another laptop, right? Okay, another laptop here, another 20K. Okay, now I can handle 60. And what happens on Saturday? Nobody asks anything, right? On Sunday, nobody asks anything. And then on Monday, I have 10 requests, and so on. I have to scale down. I don't need those two laptops to sit around doing nothing if just one is, enough, right? I have to turn those guys off, right? All right, so it is a bit complicated, right? I have to be able to kind of scale up and down depending on the load, and I don't really want to be doing it manually because I will be always kind of behind. I want to kind of do that some sort of an automated fashion. So we've been playing with Heroku, and one good thing about Heroku is that it kind of does the scaling for you, in a sense, right? You have the dynos, and then if your limit kind of is reached, you can click and add additional dyno, and then if your load goes down, you can click and get less, right? Or you can kind of allow it to do that on some triggers. So once a particular dyno limit is triggered, then it adds an extra resource, right? Yeah?
Is there a possibility that the entry point gets also overloaded?
Yes, it is possible that my load balancer gets overloaded, right? So let's say my load balancer can only handle 100K per second, and then what will happen then? Well, I need a layer above that to even direct that, right? So I would say, okay, is the request I have to do something even simpler than balancing the load here on the higher level, right?
Cloudflare, right?
Sorry?
That's kind of Cloudflare, what they are the
Yeah, exactly. Right? So there are techniques for scaling it, almost infinitely, based on geography, based on load, and so on, right? Simple HTTP requests that they can, if you only need to do some lookup, they're really efficient. I'm not actually doing any processing. I'm just doing lookup, right? So the limit here is much, much, much bigger than the limit here, because here I actually have to do some processing, right? Yeah.
I was just wondering that the entry point itself might eventually have to have 2 entry points.
That's right. That's right. So we're doing it per geography, right? If you go to Microsoft.com, it doesn't mean you're going always to the same IP address. It depends. It depends where you are, where you're doing that query from, and so on. It's doing a lot of magic behind the scenes as well.
The magic lies in DNS services that basically redirect you to different servers for the same request.
Yeah, I mean, what I'm trying to convey here is that this scaling up and scaling down is, first of all, it's not easy. Second of all, you as an application developer, you have to think about it, how it will scale up and scale down by organizing your architecture, which is very important. And third of all, we will learn a little bit more about this in the next few weeks, right? So I'm kind of just giving a context of things to come.
Do you want to talk about the assignment 3?
Yes. So the final thing for today is assignment 3. So assignment 3 has been posted today. We think it's the most fun from all the assignments, obviously, because it's the final kind of assignment for this course. So by definition, it has to be the most fun. So you can read the text. I will just give kind of a general feel, okay? So what happens is we've developed kind of a service. with some sort of API. And the service consists of your kind of web app and the clock, some sort of a worker, right? So you have some sort of logic here. You have an API to it. And what we've been doing is we've been kind of pretending to ask the API for some stuff using a web browser on raw ports that you've been using for testing, okay? And by the way, you also have also integrated a MongoDB as part of the persistence, right? So now what we want to do is we want to decouple that user from here. The user will not talk to your service directly. We will kind of have a user to interact via a Discord channel with the bot, and the bot will interact with your stuff, and the user will interact with the bot via a Discord channel. So the user can say, what's the current exchange rate between NOK and USD? And then a lot of magic will happen behind the scene, and the bot will respond, the exchange rate between NOK and USD is this, okay? To do that, we will use a service called Dialogflow, which has been purchased by Google. And we will instantiate a kind of a currency conversion natural language processing unit, which is able to understand some utterances about language, about currencies. And this thing, what will happen is here you will install webhooks, which will call your API. Yeah, in fact, it will be not this particular API. You have to write a little bit of logic to deal with this API, right? So you will write another web app, which will talk to your old. It can be kind of integrated, like this module can be part of this, right? But it's just that it has a slightly different API now, because this thing will talk to your web app hooks, will pass some of the utterances the bot is able to understand and decipher, will ask you to get the data, the currency exchange rates and so on, and generate the response back, so then the bot can talk to the user, right? So there is a little bit of magic with webhooks and kind of RESTful APIs happening between the Dialogflow instantiation of the bot, your new small web app which understands these data structures, and your old web API which allows you to get the currency exchanges, right? So assignment 2 stays as is. You can reuse the API that you've used by making the new logic to talk to it to this, or you can, which is kind of the nicest way of organizing it, or you can integrate it as part of your web app to add additional kind of webhooks for the bot to call into, and then you can reuse the logic internally. Whichever is easier for you. I quite like this architecture because it organizes the what is actually happening a little bit better, and it follows a little bit more like a microservice architecture better, right? You're not generating kind of a one giant monolithic system. You're kind of decoupling the functionality into smaller chunks, and which are easier to test, easier to debug, and easier to plug and play together. But if you really insist, you can kind of don't do it as a separate app, you can integrate it here. And yeah, that is pretty much it. So we can discuss it tomorrow again.
Groups.
Yeah, so logistically, the assignment 3 is a group assignment. Because we felt it is a little bit of extra work, and also you have to specialize a little bit more in who is doing what in terms of understanding the deployment and the logic. We felt doing it as a group assignment will be better for you. So groups of 2 or 3, you have to kind of do 3 things. So one thing is you have to do the bot and understand how this part works. Second thing, you have to hook everything together, so using the kind of the webhooks and the callbacks. And third thing, you have to design it as if you were not using Heroku and MLabs. as if you were kind of deploying it on a private held cloud computing infrastructure, which Christopher will talk about in the next and following week. So we will use Docker and Docker Compose to teach you how would you do that if you didn't have Heroku and if you didn't have MLabs, if you were doing it yourself, right? How would you organize your development and deployment? The groups, in the assignment 3 on Blackboard, we have a form which we would like you to fill in. You pick yourself from the list. We got that list from the Blackboard, and then you put the group name that you belong to. So we would like you to generate a unique name of your group. If you don't do that, it will be trouble. So try to generate a name of your group which is unique that nobody else took, and then agree on the how you spell it, right? So make sure that all your group members spell the same group the same way, so it's easier for us to match you into the group. Okay, so 2 things: generate a group ID for your group uniquely, and second, make sure everybody from your group uses the same spelling, and just register your group. Deadline will be Friday. Did you set the? Okay, so this is already live. We will take it down on Friday evening, and then let's say 8 p.m. And then everybody who is not in a group will be allocated to a group automatically, right? So we make you choose your own groups yourself, allocate yourself to a group. Feel free to do that, groups of 2 or 3. If you don't do that by Friday 8 p.m., you will get allocated to a random people and you will be doing the assignment with those people. Questions about this? If you have questions, we can discuss it tomorrow. All right, so that's it for today. So thank you and apologies, we went a little bit over time.